This demonstration is about the use of direct access files, and in the direct access files, the record length should be specified, and at random we can access the um, particular records. We do not have to go for the sequential access to the records. So let's see how do we proceed. So I write the program df file, implicit none, and there is end program. So the record length basically specifies the number of characters to be stored in one record. Um, so I declare variables, a character variable that can store, say, 20 characters. I write AA and BB. I require integers, so IJ, and the variables. More variable, real variable. For example, I write nuclei. No, for real, I will first I write a character variable that can store the, say, at least 3 values. So these are going to be the nucleides, and then I declare a real value for to store as the cross section value, and I define a file, unit 10. The file name is cross section.out, and for this file we will define the attribute access, so that will be direct. And the other attribute status unknown, and the particular character of the direct access file is the record length, that is 20 characters will be identified as a record. So let's first read the data and store it into a direct access file. So I go for the reading. Do I varies from 1 to 5, and I write here a read statement, read asterisk nuclei, which is a character variable, and the cross section is going to be a real value, and with the reading I write these values to an internal file AA in a format I say 1x 1x, then A4, then 1x, and E 10.3. The values of nuclide and cross section. And now I write it into a direct access file. So AA variable, this is considered as an internal file. So this has the same length as the record length. So I store the value on unit 10, and this is going to be the record. This is going to be a yet record on the direct access file, and the value that will be stored is the AA. So A value is for the first time, it is considered as record first, then record second, record third, and do. So let's see what type of file is created and how it is different from a journal sequential file. So I save the program in the program directory, which is the program directory is visible. The program directory is visible from the title of the bar. So compilation step G77 da5 dot for minus da5 dot exe. So the file has been compiled. Let's see the file from the directory. So da file dot for and the file name was, let's look for the latest file. It was cross section dot out. Unit 10 cross section dot out. Okay, I didn't run the program. So df file dot exe. It requires some data. So for example, I give for hydrogen. So hydrogen sometimes cross section value 1.29 e raised to the power minus 4. Then 5 values are required, as our program suggests. So next, say for oxygen, 2.39 e raised to the power minus 3. Then for iron, I write 4.9 e raised to the power minus 4. And then for uranium, say to 3.2 exponential minus 2. And for plutonium, 4.1 e raised to the power minus 1. So 5 values which are nuclide names and their cross sections. These values are going to be first stored into an internal file AA, and then this is stored as a record in the unit 10 in the direct access file. The program has been successfully executed, and now see the new file created, which stores the data values of cross section, hypothetical cross sections. And let's see. So this is the direct access file. So we have hydrogen, first record, oxygen, second record, iron, and uranium, and up to plutonium. So these records have been saved. And now let's look for the utility of direct access file. Then we can call any record at a time directly. We don't have to go for the sequential reading and writing. So first, now I will read the data from the direct access file. So for example, I say j equal to 3. I'm interested in third record. This is record number. So this step is a record from a direct access file. So j equal to 3. Let's look for the third record. So I write a reading statement to read from unit 10 and the record number is required. So record number J, it is required. I stored the value in character BB, and then I print the value. Well, before printing BB, well, I can read the data from BB, read from BB, just like the record, nuclide and cross-section form. So in the format, nuclide and cross-section form, and then I print on terminal, print asterisk nuclide and print asterisk the cross-section. So now this is to directly read the data from the direct access file, which is cross-section.out. So third record is going to find iron and its hypothetical cross-section value. So let's see whether it works or not. So I recompile the program and run it. So iron and the value has been printed. And now the final demonstration part. So let's replace a record. So for example, I want to replace a record in direct access file, say j equal to 5, and then I suggest say nuclide to be changed as neptunium and P neptunium, and the cross section value to be changed as say 9.327 e to the power minus 5. This is something I want to replace at the record number 5. So first write this one as an internal file to BB with the particular format. So nuclide and cross section, they are now being written on BB, and then this is internal file. So now I write it on the direct access file. So write then and record number 3. So fifth record should be replaced by the new values. So now I save it. And let's also change another record with the same set of lines. And this time let's use record 2. So I write a nuclide as say magnesium, and the cross section hypothetical value 3.267 e minus 2. So I'm going to replace two records at J5 and J2, and the procedure is the same. I first create an internal file and then I store the values. So let's see the file, direct access file. It contains the data stored as records And we have the nuclides, hypothetical nuclides and their cross sections, hypothetical cross sections. And we want the fifth and second record to be replaced. We have provided the values in the file, and then now we are going to replace them. So I compile the program and run the program. So let's see whether the records have been updated or not. So this file has been modified by another program. Do you want to reload it? Yes, that's fine. So let's see the records. So 1 iron. Yes, it has been done. So hydrogen, oxygen is replaced by magnesium, and the record of plutonium has been replaced by neptunium. So that is the direct access file accessing the records directly, and it is characterized by a um, an attribute record length, which is the number of characters stored in one record. So in this demonstration, we have seen the use of internal files and also the use of the direct access file, its facilities to access a record when it is required, and also replacing a record. So with this, I hope that you will be able to work out with the direct access files as well.